Hello everybody, I'm JetAnka, the team leader of the JetAnka Orion team. Our team consists of two members, myself, who is responsible for the software and subsystems, and Talha, who is responsible for the mechanical engineering and CAD design. Also, our consultant is Ibrahim Edis, who is a teacher from the Kichuan Science and Arts Institute. Today I will talk about some of the rover's design choices and electrical choices. Our Orion is built for the main three MRC'26 missions: autonomous pathfinding, lunar drilling, and the night mission. It features a four-wheel skid-steer chassis with a 100 mm suspension system, 3D printed PLA frame, and is powered by a Raspberry Pi 4 as the main computer and two ESP33S3 models for motor control and communication. For perception and navigation, we use a high-quality IMU for orientation logging and a Raspberry Pi camera for perception. Also, we use a GPS module for waypoint tracking. The motors are driven by BTS 7960B motor drivers, and that's also powered by a 3S 5000 mAh battery. The robotic arm uses a TD7120 MG and a MG 996R servos controlled via PCA 9685 servo driver with a custom gripper for sample collection. For the science mission, we have a custom drilling subsystem, a load cell with a HX711 amplifier, and a moisture sensor for the soil analysis. Communication between the rover and the ground station uses the NRF24L01 models with external antennas.
Hello everyone, I am Talha. Now I am going to explain the design aspects of our rover in more detail. In the suspension system, we use the structure that separates the wheels we developed ourselves into two independent suspension sections. To prevent the system from being too rigid, we designed it with a spring-based suspension. We also used bearings to minimize friction within the suspension. For the wheels, we adopted an open and spacious design that provides strong traction on soil. This helps increase grit while preventing the rover from sinking into the ground. We designed the rover with two main sections, a lower body and an upper body. This allowed us to create a spacious interior. In the lower section, we planned to place the battery and the main computer. We also added a cover to make these core components more accessible. Ventilation holes, along with additional fans, help prevent overheating and ensure proper airflow circulation. In the drilling system, we used linear actuators that we designed ourselves. These actuators provide a long range of motion, which makes the drilling process easier to perform. We also plan to use a screw-type drill bit that we developed, allowing us to penetrate soil efficiently. Additionally, we used a second linear actuator for the load cell system. We have a 50 kilograms load cell which will allow us to measure the compactness of the soil. In the upper body, we left a more open area compared to the lower section. This space is intended for sensors, a camera, and lids that can change color depending on the mission. To store the soil collected from drilling, we designed a removable container that can be attached or detached depending on the mission. This container allows us to transport soil samples safely without mixing them. For the robotic arm, we aimed for a more compact and simple design to reduce complexity. We aligned servo motors and other components along a single axis to create a balanced and stable robotic arm. This helped us distribute the load more evenly. We also secured the servos using heat-set inserts to improve stability. At the end of the robotic arm, we designed three different gripper types for different tasks. Two of them follow a simple and lightweight design approach. The first is designed to grasp various objects, while the second is optimized for handling soil. The third design is still under development and features an electromagnetic gripper that can hold objects using magnetic force.
As you can see, our rover is nowhere near being perfect, but we are actively trying to make it better. With lacking funds from our institution and me using my own printer to print out the rover parts, we were not able to print the full rover out in time. But we promise that we will have the rover ready by the competition days. Thank you for listening to us.